is more important. So important is the way have the file here. This is the PDF, this is a video file. Okay, this recorded video tell you how to record the video file. Okay, there is a function you need to learn just how to record the video. Okay, just keep in mind, in case you cannot for the project, in case you cannot generate a recorder file, that's fine. You still have 90% of your credit for the project. Okay, because the way required, you generate a recorder video file at the end for the project. In case if you have trouble to generate the recorder file, the video file, okay, you can still complete the remaining parts. That will give you 90% of your credit. The generation of the video file only give you extra 10%. Okay, just keep in mind. Don't worry. In that case, you cannot complete the last step to generate the video file. That's fine. You can still update your project and end. You still get most of your credit, 90%. Okay. So this is the same file, part match one. That's a grab from a video camera. And I will demonstrate. Okay. This is I modify. That's different than when last time you download, last class you download. I modify the last one, part match V2. So this is important. If you still have trouble, just download the last part match V2, version 2. Okay, I already updated this one. I will show you how to use this one. This is exactly open from your recorded video file and do match, part match, select the template. Okay, so also important, I give you extension for the project until May 5, May 7, that's Friday, okay, evening. So you should be submit your project. I give you 2 weeks extension. Previously, you should be begin project 2 because so many people have trouble, so we cancel the project 2. We don't need to go over project 2. Instead, we put the remaining 2 weeks to give you extension. In that case, I believe you should be more comfortable, have enough time to complete your kind of project 1. Okay. So I go over this part. I quickly go over. Okay. And project 1. So what you need to do, because some students still not understand what you need to do. The procedure is important. You need okay. Here, okay. Here is you just required to generate. You already have a video file. Okay. The requirement is you open a video file and change the image motion because this image is taken by a small telescope without the motion correction because the Earth's rotation. You can see in the video. The image is rotation from time to time. Okay, if you play this one, okay, this video file, you can see very clearly. Okay. Okay, you look at the Jupiter. This is Jupiter. Okay, moving from time to time because the Earth is rotating from time to time. So what you need to do, you need to move this one to some fixed point, each frame to some fixed point. So in that case, you should be seeing the image is fixed somewhere. Okay, without moving. Okay, without moving. So there is a several frame of image you can. When you play with the video of another view, you can see several number of frames imaging. So you should be running this code in a for loop to correct the image motion in a for loop. Okay, for the loop. For example, you can move every image from the current position to the fixed position. For example, this is very close to the middle of your window. 500 pixel X coordinate, Y coordinate 500 pixel. We assume that's very close to the center of your window. For example, your window have 1,000 pixel X and Y direction. Okay, so your window have 2 directions. That's why one is X direction, another Y direction. You move it to some point, fixed point, and going close to the center. So when you generate a new video file, you play this one, you should be see your imaging located on a fixed position. In that case, okay. I believe I maybe have one video not have be correct. I'm not quite sure. I sent it to some students, but not to everyone. A couple of students. Okay, so let's give you an idea what it look like for a correct imaging. Okay, I hope I can find someone somewhere. Okay. Okay, I can show you if I can find. Otherwise, you cannot see. Okay, the project. Okay, is 19, and I have a look here. Go. No, here. Maybe you go 17. Okay, pattern match video. Okay, not this one. You need to have a project. Have this one. Project. Okay. No. Okay. 2016. No. 2020. No. Great. That's this one. Okay, maybe I cannot find that one. Okay. Okay, maybe I cannot find that one. Okay. Anyway, okay. In that case, if when you play the video, this one should be on a fixed position. Okay, when you play, each frame should be on the same position. Okay, you can see. And in that case, you can add the imaging directly. So in that case, you can increase signal to noise ratio because the background is randomly changed. This is the signal is proportional to the image number. Other background is randomly changed. So in that case, signal when you add more imaging, signal will be increased. Okay, so that is the one you're required to do for your project. Okay, here is I give you the procedure. Okay, because some students ask me for the procedure. Okay, here is exactly the procedure you need to do. Okay, you need to select Jupyter as a imaging template. Okay, because you do the pattern match here, you need to use the pattern match to find the position of Jupyter. Okay, you look, the Jupyter is moving, so you should be select Jupyter. Okay, around the Jupyter. Just select a template, very small template around the Jupyter. Okay, the Jupyter should be template to do the pattern match because it has a clear structure feature. You look, select this one, select, okay, select around this Jupyter, okay, as template to do the pattern match, find the current position for each frame. Once you select template, you do the pattern match, you should be able to find the current position. Once you find the position, for example, the difference in X direction, for example, this is 500, and this is 700, for example, X direction. You have 200 difference, okay? X minus this X 0, and give you the position you want to move in x direction. You can do the same for y. So both x and y, the delta x and the delta y, the x direction difference and the y direction difference, delta x and delta y is exactly what you need to move. Okay. When you use the imaging shift, this function. Okay. And once you correct, you can sum all the imaging together to get a final master imaging. So that's give you good imaging to noise ratio. Okay. And you find you can save this one as a video file. Okay. This just take a 10% of your credit. Okay. So this is the exact procedure you want to do. First, select Jupyter as a template to do the part match. You need to have the template. Just Jupyter. Have
Professor?
Yeah.
Do we choose the template before we run the program or after it runs once?
Oh, that is your first. Once you run the program, the first thing you need to do, once you open the video imaging, the first thing you need to do is select an imaging template. Okay.
Okay, then, so you first select the template.
Yeah. Okay. First thing you need to do, to select a template, you need to open a video file. That's right. You can select any frame from the video file as a template. Okay. I will show you. Okay. Yeah, that's good question. Yeah. The first thing you need to do is open a video file. Select any frame. You can use any frames. Select a template. Okay. Template. Once you select template, you can do again. Put in a for loop to do the pattern match. You find the x and the y coordinate. Once you find the x, y coordinate, you can subtract with the fixed position, find the delta x, delta y to move the imaging, use mark shift in the for loop, all done in the for loop. Okay. And then you play the video, you show the imaging, you should be seeing the imaging. So in a fixed position. Okay, I show you here. Okay, here is the free imaging. Okay, free imaging. This is a video, Jupyter video. Okay, so in three code I provided. Okay, this one tell you how to record the imaging. I will show you later. Okay, this is pattern match. Okay, the important is the last one. The last one I already modified. You look here. This open an imaging file, a video file. I just modified. Previously, you have one here. You have one here. Read a video file. Previous class. Okay. That's it. Put in a for loop. I just remove the for loop here. For loop here. Not for loop here. You don't need the for loop because I just read one imaging. Okay, I just need to one imaging from frame. Okay, look at the help here. Look at the help. I open the context help here. This the first part is the same. Is the same with this example file, the same exactly. But here is you put in a for loop to read all the frame imaging. Okay, here look. This is the frame number you need to read. I just read 100 frame number. Okay, 100 frame. Okay, read the first frame. That's up to you. Okay, because 100 frame number is good. You look at the imaging is moving from here. 100 is somewhere frame number. This may be 200 here. The imaging move to here. I just want to select a good frame. The imaging is very close to the center of the window, so I'm comfortable to select. Okay, so this open AVI file, select one frame. In the previous one, we put in a for loop. Okay, and here you have the information total number of frame. This one can be y to the n of your for loop, the iteration number for loop. Here I just open one. Okay, so once you open, we still use the same code with this one, okay, with this one. This is I will play later. Okay, I just this one is select. You know this part very well. once you select the image, you feed back to select template. We use this part again and again in our part match example code. You know very well. Okay. Once you select your output here, at the same time, this one, the original frame is goes through here. Combined with the select the template here, so up here. Here is you also show the imaging here. That's why the original imaging here. Okay. Once you select this frame, you need to show this imaging, and in order to select template from this imaging. Okay. This imaging go all the way. Combined with your select template go all the way. So in that case, you can do the part match. This landing. The template you need to go to landing. Okay, you only character for ship, find the ship, no rotation. Okay, and here you do the part match here, original image and the template do the part match, give you x, y coordinate. But is a cluster. You need a broken the cluster to give it a x, y coordinate, and this give you position x, y. This angle, this scale, how much you can scale the template to much better. You can also rotate the template, but we just shift, no rotation. Okay, we know very well. Okay, no rotation. Okay, give you this one, you get this also cluster. You look at the color, and the cluster explode as each element x and y. Okay, x, y. Okay, this is so your x, y coordinate, x, y. Okay. Here is a, so you need to make a drawing, okay, template, make a circle, and this is XY coordinate here. This XY coordinate cluster you spread out as a element, you look as an element. Let's give you XY coordinate. So that's very simple. You can do the same, put on a for loop, okay? Begin from, once you have the template, you put a for loop, you already have the name, okay, here. Okay, just put it here and put in your for loop. Total number you already have. Okay, total number of imaging or you already have the frame number. Just put a for loop. Okay, do the same. Just move this imaging here to wire to here. Put in your for loop. Okay, you can add another frame. Okay, you can add another frame after this one. Okay, add another one. Okay. Add another frame after and so on. Okay, after you can put a for loop to find and do the pattern match when similar to this one. The good is you already have the template. That's a template here. Okay, you just give an example. If you don't want this part, you just remove this part. You put in your for loop because you already have x, y coordinate. You subtract it in a fixed position 500 by 500 x and y. You find the difference, put in your for loop, and find the data x, data y, and move the imaging. Use the Emacs shift to the specific position according to data x, data y in a for loop. And play the imaging. You need another one, play the imaging. Okay, and so you're done. Okay, you're done.
Professor?
Yeah.
So what's the point of the x and y out of the for loop when because we already feed the position to the image shift, right?
Yeah, exactly.
So what's the point of the x and y on the outside? Is it just there?
Data x, data y.
Is it to the right of the for loop?
Yeah, exactly. That's exactly, you need to put in your for loop here. You need to do every frame imaging here. Because you already have here, you look, you already have the frame number. You can use this one to wire, to go all the way, okay? To go all the way, you take some distance, but you can still use the number, okay? For example, to wire here, can tell you that how many number you need to go. So this will go each frame, okay? You can do the same, okay? To do the pattern match again, here, when similar to this one, to do the pattern match again. The difference is you need to replace this one with here. This n will be changing from yeah, from when you open this one, you look at this read the imaging. You still put here, this one here. To read the imaging, begin from number one until the last end. Okay. I believe it is begin from 0. Okay, begin from 0. We have one code, I believe read here. Read the AVI file. Okay, this one exactly how to read the AVI file. Each frame. Okay, just copy some part, not code to here. Okay, to here exactly. And you have each imaging, and then do the same. Replace this one, the pattern, the template you already have. That's why. Just do this one again. Also, once you have the data X, data Y, we need to like this one, you're done. You replace the one, but data get data X and Y, find the data X, data Y immediately, and move the imaging here. Use this function. Okay, imaging shift. Okay, so you're done. And then if you want, you can add the name. Okay, the next step. Okay, it does make sense. Okay, so here, okay, so here I run this code again. The last one, the part match 2. Okay, I would like to run it to you. Okay, from beginning, so you understand what it do. Okay, so that's important. Okay, here. Okay, this version 2. This new one I just put. You can look at template imaging. Okay, this imaging is because you want to select from imaging. I need to have imaging here. You select from here. Once you select, you need to show the template to make sure it's the correct template. Yeah, this one. And then the result give you an idea how good the pattern match is. Okay, and I do a pattern match here. You can put it in a for loop here. Okay. Why is okay here? I make a drawing here. You can keep this one or not. It's up to you. Okay. This is just for visually show the result. Okay. I make a drawing, a circle around the template from the current template. Okay. Okay. Run this one. This one is open the video file. Okay. Exactly. Just one frame. Okay. You can fit. Yeah. Okay, this Jupyter, okay, you select this one, let's give a template. And then this is a batch result, exactly. You find the Jupyter from current frame. Okay, in case if you don't want a 100 number frame, you can change this one. Okay, I change from 200 because 100 number is, you look, is too low, and maybe 200 Jupyter already move somewhere. I can run it again, you look. It's up to you, okay. The select template is up to you from which frame. Okay, you look at here. It's 200. Go to here. That's more comfortable, maybe. Okay, it's up to you. Okay, you can still do the same. Template go here. Okay, so that's done. So you can use this one as a startup for your project. So this one, I believe I already done almost. This one already include the select open the video file, select template here. Also give you the template imaging, look at here, to do the first part match, okay? Actually, you can, based on this, you maybe combine the two parts, find the X, Y for each frame, just put it in for loop. If you want to keep this one, that's fine, okay? You already have one example to do the part match, only one frame. Here, you need to put in a for loop, okay? Combining this one in a for loop to find the X, Y, and then immediately subtract a constant value, X and Y coordinate. In that case, you move the imaging, okay, you move the imaging each frame to the fixed position here, okay. You just need to find the data X, data Y, because you know this function, how to use the imaging shift function. You need to input the data X, data Y, that's right, okay. So that's what, okay. So yeah, so that is the first one frame imaging. Okay, I need to demonstrate here. You might be careful when you use this one. I have this two example. Okay, these two example code, but just give you an idea how to use this one. Okay. Okay, I close the current one. Okay. Okay. we still have another two example, okay? Another two example, you look here, okay? This one is also select AVI file, okay? Or we run, have a look, we can run, okay? You look here, what's asked you do, okay? You open an AVI file, okay? AVI file, okay? Almost the same, okay? Almost the same. So that's the first one, okay? Okay, this one much lower and much fit room to fit the window. Okay. Okay, almost the same. Okay, this one almost the same. Okay. Still do the part much. Okay. But another one is different. How to save the video? Okay. This one here, you go to here, the first one. The first one give you an idea how to save a video file. Okay. Here is okay. So if you look at here, it's asked to select a camera. The kind of my computer have a camera. This laptop, all the laptop have a integrated camera. Okay, I select one camera because here is a grab the imaging from the camera and to show the kind of imaging. And here is function. This function tell you how to save a video. Once you have the imaging in a for loop or while loop, you just use this function. You divide give a name, okay. Give a name to save the imaging, okay. Select a path to save the imaging, okay. And then use this function to save the imaging, okay. That's a project, the path. You already have a for loop. You just use this one and divide the name, okay. Divide the name, and you can use the function to save the imaging. And then after you're done, you close the video file. Okay, so I play this one just carefully. That's my camera. I give it a name. Okay. This ask me to open this one. Overwrite my imaging. Okay, that's fine. Okay, just be careful. It need to overwrite my imaging. Okay, and then okay, what's it to do? Oh, something wrong. Okay, I don't know. Okay, maybe I need to run again. Okay. I believe this one should be right. Okay. Select a path. Okay. Maybe I need to change it.
I think it was doing the same thing to me, that like it would only take camera, it wouldn't take like a
You don't have a camera. Maybe you use the laboratory computer. Laboratory computer, that's a desktop, that don't have a camera. Okay. You can also play this one. In that case, I believe. Yeah. Okay. In any case, this is a grab from the image. I need to choose correct and you need to select correct camera, okay, in order to play this one. Okay, something wrong. Okay, but anyway, I believe I need to begin from start. Okay, I need to curtain out another view. Okay, make sure this one can play. The video file can play. Okay. Okay, you can still play. Okay. Okay. Anyway, this one is the last function you use to save your imaging. Okay. Okay, just take a little time. Yeah, select this one. Normally, the first one is should be work. Okay. I use the same name. I don't know why it not work now. Okay. Okay. Anyway, you don't need one. This one is the only function I use here is give you idea. You use this function AVI writer. You divide the imaging. Okay. You divide the image. You give a name. Okay. This give you an idea how to write a name. Okay, how to write the name. New or existing. Okay, this one is oh here. This one is okay. Okay, you just use this one. Okay, the last function give you an idea. The last function generate a AVI file. Okay, AVI file. Okay, you for your code here, you can put in the for loop AVI write. That's one in your for loop. Okay. If you have a generator of for loop somewhere here, you can put it in a for loop here. That's one to write each frame image, and you generate the AVI file. Okay, okay, okay. So that's what I can tell you. Okay, so we come back here. Okay, so this is our last class. Last class we skip project 2. Okay, we only needed to do the project 1. Again, I repeat, the May 5 Friday is last day evening, is last day to upload. Once you complete your project, just upload to OneNote. Okay. Again, if you have trouble to write a video to generate a video file, okay, you can skip last one. Let's give you 90% of your credit for your project. In that case, okay. If you have trouble, otherwise you can use this one, the example code, and okay, just put this part in your for loop. You should be able to generate. Or you in other case, yeah, you need to test this one. You open that image, and then you can put in a for loop to test this function, how to use it. Okay, AVI write frame. Okay, so that's very simple, this one. But before this one, you need to give a name. Give a name. Okay, here, give a name. Okay, give a name and include a path of that file. Okay, and then this one is create image. Okay, you need to combine these two functions. Okay, only. Okay. So any question?
Yeah, Professor. So when you made the pattern match 2 VI, it was before you had made that, I was working on mine based off of the original one. I was trying to, and I created basically what you had with the pattern match 2 VI. But I was getting a compatibility issue with the video, still getting a compatibility issue with the video and the pattern match VI. How did you correct that between the pattern match 1 versus pattern match 2?
Oh, don't worry about pattern match 1. You said that the example code, and that's why this one. Yeah, this one just to give you an example. I don't think you can run pattern match 1. Okay, because
no, you can't. But I was using the read VI to allow me to run, so I was able to start running it. But then like after 2 seconds, it said that I couldn't run it anymore.
Oh, so you don't allow to run pattern 2. That's right. The Vision 2. I understand what you say. You say you can also run this one. That's right.
No, that's not what I was saying. Before you made the second pattern match VI, or because I wasn't able to run that one originally, I was using the pattern match 1 and trying to and did what you did with the 2 and 2, where you take the read the VI and export it into pattern match 1, but without the whole what's it called? Without the image, without the for loop and everything, and I did all the replacements, but I was still getting a error, and I was wondering where.
Oh, yeah, I know. So you have error. I forgot. That's my problem. I use my version, my W version. My W version is a high version. 2018. You are 2020. 12. So I should be correct this one. Okay. I should be correct this one. How I correct this one? I should update again now, maybe. Okay. So yeah, I use my version, my kind of version, I save as my kind of version 2018. Yeah, you're right. Yeah, good question. I should be saved as a previous version. You look at previous version, my kind of 18. I should be saved as 12. In that case, you can run it. Okay. You should be having no error in this case. Okay. Okay, I save this one. I should be updated. That's my mistake. Okay. I should be updating this one. And also another is I have a look at another one is this one. That's right. This one. This one you don't just run, you just need to look in this code. Okay. You open look at this code. But I will update in this three. Okay. This three. Pattern one. Give you what's okay. Pattern match. This part two. Okay. I would immediately update. Okay. You don't need the one. Okay. After the meeting, I need to update another one. Okay. This pattern two, you look at after I update this one, you should be able to run. Maybe I can now update this one. Maybe. Okay. Okay. The most important is pattern match version 2 v2. Okay, that's more important. Okay. I believe I can update immediately. So it goes from here. Okay. Yeah, this is the kind of one. I deleted this one. I use the one I just generated. Okay. And actually you can run this one now. Okay, just make sure. Okay. Yeah, you can run this one, I believe. Okay. I already updated. Okay. Yeah, this one. Yeah, you can download it now. You can download this one. This is more important. Based on this one, you should be able to run. Can you try this one now? You download this one, you run it again. You should be working. No error. If this one can run, I will update pattern match one. Okay. Pattern match one is most important because the pattern match v2 include everything you need. Yeah, this is a pattern match video, and can you run it now? So it's good. You can run it now. Just try. I believe it should be work now.
I'm trying to get
Yeah.
the
Yeah, just make sure it's working now. Okay. Yeah, that's be good. If you can run the pattern match, I still also save as a previous version 12. So in that case, you can work on it. Still save as 12, version 12. Okay, this one I also save here. The first pattern match I also saved here. Okay, I can save the replace the previous one. I believe both code you should be open now. Okay, this one I also remove. Okay. Okay, audio update. Okay, so now both this code should be open. For the first one, I don't expect to run it. This one just to give you an idea because you have no camera. Your laboratory computer have no camera. Okay, the first one just give you idea how to use this function, these two functions to generate a video file. Okay. Okay, you okay? Can you run? The first one.
I'm trying to open LabVIEW right now.
Okay.
It's kind of slow when I'm in Zoom and
Take some
on
time. Okay.
Professor, I have a quick question.
Okay.
So for the final image, the image that I got didn't seem like, I mean, it didn't look all that much better than the images in the video. I don't know, like, I mean, I know it's supposed to improve the signal to noise ratio, but is it supposed to like actually like look better? Like, can you actually, are you supposed to be able to actually see
Okay. Okay.
Jupiter better?
Yeah, the resolution maybe not too much, but the only signal should be slightly better. Don't worry this one. Okay, but in principle, if you add more imaging,
Yeah.
together you should be the signal should be increased. But the situation is this imaging is distorted from time to time because the atmosphere field turbulence. Even though you see the imaging is distorted, the Jupiter distorted from each frame to each frame, the actual result not so good. So that's but in principle it should be good. If Jupiter have low distortion, then if you add more, the signal should be much better compared to the noise. Okay. So don't worry this part. Yeah, just give you an idea. Okay. If you add more, if the imaging is really more large number, then you definitely see the difference. The kind of one, the video one, not too much frame imaging. Also, in addition, the Jupiter have some distortion. You see the shape of the Jupiter change from frame to frame because the atmosphere turbulence distort the Jupiter imaging. So the net result not too good compared with the series. Okay, in series should be much better. Okay. Okay.
Professor, I was able to open it.
Okay, you can run the code now. No error.
Yep. So far, no error. I'm gonna try to run it and see what happens though.
Okay, good. Okay, so the two code can run, you can run the two code, okay? The pattern match 1, pattern match 2, I already committed to your version 12, so you should be able to run. And I expect you can use the pattern match V2 because I already, it is exactly what you can use to select a template. And then what you to do is update the code at the end of the code second at the end of code somewhere you can put it in a for loop, okay, and put it in a for loop to do the remaining part. Okay, this you can run this one. This is exactly what you need to select template and put it in a for loop somewhere here, or you combine these two. Okay, last part put in a for loop to do every part to get the XY coordinator, XY coordinator, and find the data is data Y, and then use the imaging shift correction also puts in the for loop. You can do everything for the remaining part. Okay. Okay, so that's what I can tell you. Okay, any other question?
So essentially, you have to use pattern match and create another for loop with the modified positions and add them with each frame.
You can modify the feature. What you mean? Actually, if you want to modify, that's fine. Okay. Yeah, but here is you use pattern match here. You use a template, look to find an exactly same feature in the imaging. Okay, you can do here. Use this template. That's right. This you find the template exactly find the same structure in the frame imaging. Okay, you put in your for loop. That's right. You can change the frame, each frame image, and the pattern match find the same feature of the template and the specific position in that frame. Okay, so that's what you can do. Okay. Also here is a number, the number should be 1. That's right. The number is 1. I just input 1 because there is one Jupiter only. So you need to find it. Okay.
Do we have to go frame by frame?
Yeah, exactly. You need to put the frame by frame. That's why you need to put in your for loop to do exactly frame by frame. You can combine it into one, but this give you an idea. You only do one frame. You can combine this two part. Okay, these two part for loop, and each for loop give you data, give you x and y coordinate. You subtract x z position 500, for example, y position 500, give you data x, data y. And you also put the image shift in the for loop. Yeah. So that's give you, when you put the for loop, you do one frame by one frame over all the frame of the video. That's right. If you don't want, you just keep it here, you add another your for loop behind this behind this end of this code. So that's fine. Okay. This just give you an idea. You don't want to modify it. That's fine. You add your remaining code after at the end of this code. That's fine. You add a frame after this one. Okay. But you still need to go put in your for loop to do the pattern match on every frame. Each frame after another frame. Okay. And you also show the result when assuming this one. This one is I put here. You don't want making a drawing, that's fine. No drawing of a circle to indicate the position, that's fine. But you need in the for loop is good. You have another window, another image display window to show the result when assuming to this one. Okay. So in that case, when you run your code, you can see how your code is running. Just make sure it is what you expect. Okay. Okay. Other question? Okay, so yeah, if you know any question, we just end here. So we have no class, just upload your final code in the OneNote before May 7, Friday. Okay, I give you 2 weeks. Just make in mind that don't do everything in the last week. That's not very good. Okay, just if you can, just finish your project in the first week, in this week. In the case, if your submission run connection problem, you have enough time to fix that problem. If you go do everything in the last week, last day, and in the case you have a connection problem, then you have no enough time to fix that. Just have a good plan. Okay, have good plan to do complete your project as early as possible in this week. Okay, the next week just you can keep in the case you have something. Okay, extra trouble. Okay, in that case you can use the last week. Okay. Okay, so we should be ended here. Okay, thank you everyone. Okay.